Okay, so the medical researcher is comparing two treatments for lowering cholesterol, diet and medication. That's the ancient debate, right? What's better for health of the body? Is it diet? Oh no, normally it's diet or exercise, huh? But now they're going diet or meds. Okay. Anyway, the researcher wants to see if the patients who receive the recommendation to change their diet have equal, notice that word, very important, tiny little word, gigantic little word, equal success. Super, let me underline both those. Equal success. Now yours might say greater success or less success. It depends. They change it up. Lowering cholesterol compared to a prescription of meds. A random sample of some patients who received the recommendation to change their diet and others who were prescribed meds was taken. The results of how many did or did not are shown below. So here's the results. So understand what this is saying? Data on diet versus meds for weight loss. So here's the people that decided to just manage it by dieting. And the question is, did or did not they lower their cholesterol? Yes, 521 did lower their cholesterol. Among the diet people, 521 lowered their cholesterol by changing their diet. 172 did not. Even though they changed their diet, their cholesterol did not change. And then for the people that took meds, 564 lowered they lowered their cholesterol by taking meds, and 167 did not lower their cholesterol, even though they took the meds. Okay, here we go. So first off, what's being claimed? We always start with that. What's being claimed? We have two populations here. We got the diet people and the medication people. So the claim is that they're equal, right? P1 equals P2. That's what's being claimed. Now you might have greater success or less success there, so it'd be greater or less. So then what does that mean about, and we know right here we're going to do a z-test for a difference between two populations, right? Because when we look at the calculator, I'll go back up here, the notes, the exam 4 notes, two proportions, right? Two proportions, we're going to use two prop z-test. So z-test for two proportions. All right, and they never mention there's no mean or average, right? They never say mean or average, so it is proportion. All right, so let's go down now, write the HO. What's HO? Always equal. You can do HO before you do anything, huh? HO is always equal, right? Always. What's my H1 going to be in this case? If HO, remember, one of these two is the claim. H1 has to be different than HO. What's it going to be? Everybody see it's not equals? Does that make sense? Because it's got to be different. So my problem doesn't have a greater than or less than anywhere. But when you do the homework, you might get a greater than or a less than. How do you know? Well, if instead of equal success, maybe yours will say greater success. The people on diet, greater. So then you would have greater, and then your H1 would be greater, wouldn't it? HO is still equals because HO is always equals, but then your H1 would be greater. Or if it said less success, then you'd be less and your H1 would be less. Does that make sense? Like getting easier for doing the HO and the H1? So it's kind of the same thing every time. All right, so my H1 is not equal. And let's go write the evidence. That's very important. Weak evidence for HO. If the evidence is weak, we're going with HO. If the evidence is strong, we're going with H1. All right, on we go. The test statistic. Let's come on down for the test. So it's time to go to our calculator. We're going to go, we're going to hit stat, go over to tests, go down to whatever number it is, number 6, 2 prop Z test. Then hit enter, choose that one. All right, and then we're going to have the various options. It's going to ask us for X1, N1, and X2, N2, and then we just do whatever the H1 says. Okay, so you guys with me to this point? So this is where it gets a little bit tricky, not a lot, but a little. Remember what X1 and N1 are. They're the proportion, right? Like if I said 7 out of 10 people who diet lower their cholesterol, for example. That's what X1 and N1 are. It's like 7 out of 10 or 90 out of 100 or whatever, right? That's what the X1 and the N1. N1, remember, is always total, isn't it? It's always total. And so is N2. Let me write that. Both these guys are totals, aren't they? Okay, so let's look, how are we going to find the totals? I don't see the totals here. Start over. So what we're going to need to do, we're going to need to add them. I've got to add those two on my calculator. So that's going to be 521 plus 172. I'm getting 693. That's N1. That's the total people that did the diet plan. And then you got to add the other ones. And you can just add those right in your N1 and N2. Like right here for N1, you can just write 521 plus 172. You can just type it right there. And N2, you can just type 564 plus 167. The calculator will do it for you automatically. You don't have to do it on the side or anything. You can just do it right there. And the calculator will handle it. But you do have to add them.
Which one is X1?
Just the first group. The first group is always 1. The second group is always 2.
On yours, it says like yes and no, but which one do, like, how do I know which one is X1 and X2?
So, so this column right here is X. Oh, I'm sorry. I see what you mean. I'm sorry. Yeah, good question. Yeah, so how do we know? I was thinking of N. Yeah, thank you. Well, how do we know X1 and X2? Good question. That is always whatever they're asking for. So are they asking for yes, or are they asking for no? What did they say in the word? I think this is the hardest part of this course, is all these little words. What are they wanting? Are they wanting people to succeed or fail? What did it say up there? Have equal, what's this? Success. So that's the yes. There's X1, there's X2. Everybody see how I found that? They could have went the other way. They could have said, I want to see if they have the equal chance to fail, you know, and then I would have grabbed the no's. So it's always in the words, but I know there's a lot of words and you got to read those words really carefully. That's the crucial thing you want to focus on to do well on these problems, is really get used to those words and read those words carefully. Good question. Equals success. So that's what the yes is, right? Because it says right here, the results of how many did or did not? So yes is they did. They did lower their cholesterol. They had success, right? Everybody see all those words connecting up? So it's the yes. And the real trick is you had to find the ends yourself, because the end was the total people. N1 was total people that dieted. N2 is total people that did the meds. Okay. So put all those numbers into your calculator. What do you do? The final thing is H1 is whatever H1 is. So the last thing for me anyway, mine is P1 not equal to P2, because I'm getting that from H1. It's whatever H1 is. If you have greater, then you put greater there. If you have less, then you put less there. It's whatever you have at H1. Calculate. I'm getting a test statistic, Z. Let me change my color here. Z equals what? Negative 3.526, rounded to 3 places. And I'm getting a p-value 4. Oh, it's one of those E things. Remember how those work? I'm getting, here's at least how mine is. I don't know what you guys got. I got 4.21764, blah, blah, blah. E minus 4. What does E minus 4 mean?
You move to the left 4 times.
Yeah, good job. Left 4 places. Left, so you grab this decimal and you go once, you're to the edge, 2, 3, 4. Those bring in 3 zeros, don't they? So 0.000421764. So they want us to round to 4 decimal places. So I'll put a line after the 4th spot, 0004. 0004. There it is, rounded to 4 decimal places. All right. So last question. Well, last number question. So is this p-value greater than or less than the alpha? So you're getting the hang of what an alpha is. It's how low they want the p-value. That's what an alpha level of significance test is. It's how low they want the p-value to go. They want the p-value to be under alpha to believe the results are really true and it wasn't just random luck, right? Remember, p-value is the probability that the results are just random luck. And the alpha tells you how low they want that. They want it below a 10% chance of luck. They want the chance of luck to be less than 10. Did it come out less than 10? Yeah, way less than 10. So the p-value is 0.0004. The alpha level is 0.10. So yes, my p-value is way less. Super, super low chance of luck. There's a low chance that these results are just by luck, right? That's always what we're wondering about in a statistical study. How do you know it isn't just lucky? How do you know that you just didn't happen to get some lucky people who were their cholesterol was gonna go down anyway without dieting or meds or whatever? How do you know? Because that can happen, right? You can get just lucky people, different biology and genes and hereditary and stuff like that can get in there. How do you know it's really the diet or really the meds or whatever? Well, that's what statistics does for us, is it calculates the chance that could happen randomly by luck. That's what the p-value is. That making sense? Whenever you see a p-value, understand P stands for probability. It's the probability that this results we got here, this number that got better, their cholesterol lowered from diet and meds and stuff, was just luck, just random luck. What's the chance of that? Really low, way lower than the level they wanted it to be below, right? That's what alpha is. That's how significant, how strong they wanted the results. They wanted less than 10% chance of luck. Did we get that? Yeah, way less. Really low chance of luck. So what does that mean then? So we got a really, really low p-value, didn't we? So you know the saying, right? You say it to yourself day and night. As you're going to bed, you say, when the p is low, the null must go. I hope that's working for you. When the p is low. So our p is very low, isn't it? So HO must go away. That's the saying, right? If the P is low, the null must go. If the P is low, the null must go. If the P was not low, the null must not go. But ours is low. Our P is very low, so the null must go away, which means what? Reject the null. Keep H1. Right? We're rejecting the null. So answer E is reject the null. Say bye-bye to the null and keep H1 instead. So I'm rejecting this null, and I'm going to keep H1. This is what I conclude. H1. Are we good there? That's what we conclude. Now let's put it into words. So was the evidence strong or weak? Strong. Mine was, right? Strong evidence. Statistically insignificant? No way. Statistically significant? Yeah. Significant? Yeah. Those are good. Insignificant? No way. All right. We're down to 2 answers. The results were strong evidence. Significant evidence. All right. Let's read on. So there is sufficient evidence. Is that right? Yeah. Again, that's our word. See how this one says, oh, they both say that. Okay, sufficient evidence. Okay, they're both good so far. To conclude what? That the population of all patients who receive the recommendation to change their diet is not equally likely. Is that right? Not equally likely? Yes. That's it. That's what we concluded. Not equal. There's our baby. That's it. What did the other one say? To conclude, the success rate for the blah, blah, receive the blah, 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 is different. No. Wait. I'm getting confused now. That's actually the right word. Hold on. Maybe I better read more carefully. Darn, these words are tricky. Let's see. So there is sufficient evidence to conclude that the success rate for the 693 patients who received the recommendation, is that right? 693? Yeah. To change their diet is different. Sufficient evidence is different. Yeah, that's right. Well, what's wrong with the other one? Now I like that one. What's wrong with the other one? So there is sufficient evidence to conclude that the population of all patients receiving it to change their diet is not equally likely to lower their cholesterol as the population of patients who are prescribed meds. Those both seem right to me, honestly. I don't see what's going on here. The results, okay, are significantly, they're significant, right? So there is sufficient, right, evidence to conclude that the population of all patients who received these guys are being tricky. I see. Oh, it's this one. It is the one I said at first. Wow. Okay. What's going on? I didn't realize they were going to test this. Okay. Look what this is super tricky. Here's what they're doing. The results of this, now it seems to say the same thing, but see right here, they mentioned the 693 and the 731. That's the total. They're getting that from right here and here. So see what they're saying? They're saying we conclude that the success rate for the 693 patients is different from the 731. Well, yes, it was different, but that's not what we're trying to conclude. We're trying, that's what's wrong with it. Why? Why is that wrong that they mentioned that? Well, remember what we're trying to do here. We're trying to prove that the population of all patients who receive a diet is not equally likely to the population of patients who are prescribed meds. We're trying to make a conclusion about everybody who gets medication versus diet, aren't we? I mean, that's why we're doing the study, right? We don't just care about that little sample. This one is wrong because this is only the sample. right? This 693 and the 710, that's only the sample. That's not what we're trying to do here, right? Whenever you do a study, you're trying to figure out something about the whole population, right? Like when they do polling to try to figure out how the presidential election is going to go. They don't just want to know what happened in their little group. They want to predict what's going to happen for the whole nation, right? When they're testing this drug here for the diet versus the medication for cholesterol, they don't want to just know what happened for this little group. They want that to tell them something about what's going to happen for everybody, right? So that's the difference in that. That's pretty tricky. So there we go.